One quick little addendum to our section 4 notes is how to do some of these compounds that are polyatomic ions. So we'll do a couple of them here just so you can get the idea. It's really easy. When we were doing, say, in our notes, we had calcium fluoride, and calcium had a +2 charge, and fluoride had a -1 charge, and we said that formed calcium fluoride, which had the formula CaF2, or even the one that had aluminum with a +3 charge and oxide with a -2 and formed Al2O3. But what happens when we get polyatomic ions in here and we have multiple of them? So how we are going to write these and do these correctly will look like this. This one has a +2, this is chromium, +2 chromium ion, and this is called a hypochlorite ion, ClO, with a -1 charge. And if you're not sure, check your ion sheet, right? If you're not sure where these are, that's where all of the polyatomic ions are. So if you're not sure where they are, go there. Anyways, we know, looking at this, that since chromium's got a +2 and this hypochlorite has a -1, that means I'm going to need 2 of these, right? I'm going to need 2 of these guys. So how I'm going to write this to indicate that I have 2 hypochlorite ions is going to look like this. So chromium's going to stay like that. Remember, we don't write the charge up above. And hypochlorite is ClO, and we're not going to write the charge because we hope they all cancel by the time we're done here. And I need 2 of them. Well, how I'm going to do that is I'm going to put that whole polyatomic ion in parentheses and put a 2 after it like that. Okay, and that indicates to the person reading it that you have 2 hypochlorite ions. We'll do a couple more here so you can get the idea. This one has iron with a +2 charge and phosphate with a -3 charge. PO4 is a phosphate ion. That means I'm going to need, just kind of like this aluminum oxide up here, just in reverse of what's going to be where, I'm going to need 3 iron +2 ions, and I'm going to need 2 phosphate ions. Well, the iron's easy. If I need 3 irons like that, Fe, okay, and I need 3 of them, that's pretty easy to do. I just put that as a subscript. But I need 2 phosphate ions, right? I need 2 of these guys. So much like what we did over here, okay, I'm going to write the whole polyatomic ion as it is, put it in parentheses, and then put the 2 after it. So it's going to look like PO4, 2. So that formula is Fe3 parenthesis PO4 parenthesis 2. Okay, and just so we don't make this mistake, let's look at 16. This is an ammonium ion, NH4, with a +1 charge, and this is a nitrate ion, NO3, with a -1 charge. Now, notice that the charges instantly cancel. I don't have to worry about multiplying anything. I got +1 and -1, so I really only need 1 of each of these. Well, if I only need 1 of each of them, I actually do not put these in parentheses, right? Ammonium is NH4. I don't need to worry about charges because, again, they should all equal 0 when I'm done. And nitrate is NO3, just like that. And since I only need 1 of them, I don't put any parentheses around it. That's kind of an important point. Up here, I had to, because I had more than 1 polyatomic ion. Okay? But if I look at something, say, like, let's scroll down here. Okay. Let's say instead of, I don't know, sodium and let's say bicarbonate ion. Let's say instead of 17 I had this. Let's say I had Na with a +1 charge and an oxide like that, O with a -2 charge. When these go to form a compound, I'm going to need 2 sodiums and only 1 oxygen. Well, when I form that, I don't put parentheses around the sodium. Okay, sodium is a monatomic ion. Okay, there's only 1 atom here. The reason we put parentheses up here is because this is a polyatomic ion. Okay, so don't make that mistake.